Dear students, today I am going to discuss electric current and Ohm's law. So stay with me for about 15-20 minutes and then you will understand the whole topic very clearly. Now, current means flow of something. When air is flowing, we say that air current is flowing. When water is flowing, we say that water current is flowing. And when charge is flowing, we say that electric current is flowing. So electric current is defined as the rate of flow of charge, that is charge flowing per second, and is given by I is equal to Q upon T. If Q is equal to 1 coulomb, T is equal to 1 second, then I is equal to 1 coulomb per second or 1 ampere. So ampere is the unit of electric current in SI system. So electric current flowing through a conductor is said to be 1 ampere if 1 coulomb of charge flows in 1 second. So this current is measured by an instrument known as ammeter, which is always connected in series in an electrical circuit because of its low resistance. Even current is a scalar quantity, but it has a unique direction. The direction of current is taken as the direction of flow of positive charge, that is opposite to the flow of direction of electrons. The direction of electrons is called electronic current, and direction of current which is opposite to the flow of electrons is conventional. Then we come to electric potential difference. To understand potential difference, suppose we have a conductor PQ, and we know that in a conductor there are large number of free electrons which move with very high speeds in a random fashion. It means net flow of electrons and hence charge in a particular direction is zero, and hence there is no current within a conductor. Because to move an electron in a particular direction, to maintain a flow of charge in a particular direction, some external force is needed or some external energy is needed. So because without external force or energy, we cannot maintain the flow of electrons in a particular direction or cannot produce electric current. Now, suppose when same conductor PQ is connected to external source battery through ammeter and key is a switch, then what happens? Because of this chemical energy of battery, each and every electron experiences an electromotive force. As a result, it gets accelerated, gains speed, gains kinetic energy, and start drifting toward the positive end of the connector or toward the positive terminal of the battery. But it has to collide with the atoms or molecules of the conductor. So a part of its gained kinetic energy is lost at every inelastic collision with the atoms or molecules of the conductor. So as a result, electron drifts toward the positive end, but with a very small velocity of the order of 10 raised to minus 4 meter per second, known as drift velocity. So the velocity with which each and every free electron is drifted toward the positive end of the conductor under the influence of external source energy is called drift velocity, which is very small. Now, this means some work is needed to maintain the flow of electrons. It is very clear. So this amount of work done in order to move a unit charge from one point to another point is called potential difference between the points. So potential difference is defined as work upon charge. If W is equal to 1 joule, Q is equal to 1 coulomb, then V is equal to 1 joule per coulomb, or it is known as 1 volt. So volt is the unit of potential difference in this current electricity. So we can define 1 volt. So potential difference between the 2 points or 2 ends of a conductor is said to be 1 volt. If 1 joule of work is done in order to move 1 coulomb of charge from one point to another point. So this potential difference is measured by an instrument known as voltmeter, which is always connected in parallel in an electrical circuit because of its high resistance. Then we come to Ohm's law. Ohm's law states that potential difference is directly proportional to current flowing through the conductor, provided temperature remains the same, or V upon I is equal to constant, or is equal to R. This constant is called R, or V is equal to IR. This is nothing but Ohm's law. So I repeat, Ohm's law, it states that potential difference between the ends of the conductor is directly proportional to current flowing through the conductor, provided temperature is kept constant. In other words, ratio V upon I remains constant, and this constant is known as resistance of the conductor. Now, when V is equal to 1 volt, I is equal to 1 ampere, then R will be equal to 1 volt per ampere, or R is known as 1 ohm. So ohm is the unit of resistance in SI system. So it means the resistance of a conductor is said to be 1 ohm when a potential difference of 1 volt produces a current of 1 ampere inside the conductor. Then ohmic and non-ohmic devices. The devices which obey Ohm's law, they are known as ohmic devices, and devices which do not obey Ohm's law, they are called non-ohmic devices. All metals obey Ohm's law. That is, the graph between V and I comes out with a straight line. But for semiconductors, graph between V and I is not a straight line. So semiconductors and electrolytes are non-ohmic devices, whereas all metals and alloys, they are known as ohmic devices. Now, factors upon which resistance of a conductor depends. Factors upon which R, which we have taken R is equal to V upon I, upon which it depends. First factor, resistance is directly proportional to length of the conductor, L. More is the length of the conductor, more is the resistance. Second, R is inversely proportional to 1 by A. R is inversely proportional to area of cross section of the conductor. Means more is the area, less is the resistance. If we combine these two factors, so we get R proportional to L upon A, or R is equal to rho into L upon A. Another expression, where rho is again a constant of proportionality, and this rho is called specific resistance or resistivity. Its value depends upon nature of the material of the conductor. Now, if L is equal to 1 unit, A is equal to 1 unit, then R will be equal to rho, or rho will be equal to R. So it means we can define resistivity or specific resistance. So resistivity or specific resistance is defined as the resistance of unit cube of the conductor. Because length is 1 unit, area is 1 unit, its volume is also 1 unit. So we can say resistivity is equal to resistance of the conductor which has unit cube volume of unit cube. So resistivity is defined as the resistance of a unit cube of the conductor, so which depends upon nature of the material of the conductor. So its units will be ohm meter, because from this expression rho is equal to R into A upon L. So units of specific resistance or resistivity will be ohm meter, or sometimes we take it as ohm centimeter if length is in centimeter. So third factor, both resistance and specific resistance depend upon nature of the material of the conductor. Nature of material of the conductor. Different conductors will have different value of resistance and resistivity. Fourth is temperature. Both resistance and resistivity depend upon temperature of the conductor. In case of metals and alloys, resistance and hence resistivity increases with the increase of temperature, whereas in case of semiconductors and electrolytes, resistivity decreases with the increase of temperature. Then what happens when number of resistances are connected in series or in parallel? Now in this diagram, third diagram, resistance in series. Suppose three resistances R1, R2, R3 are connected in series between A and B. And between A and B, a source of EMF is connected, so that V is the total potential difference between A and B. Let I is the current flowing through a circuit. Now in this case, current flowing through circuit through each resistance will be same, but potential difference across each resistance will be different, because we have different potential at different points. Therefore, by applying Ohm's law, if V1, V2, V3 are the potential differences across R1, R2, R3 respectively, then by Ohm's law, V1 will be equal to I R1, V2 will be equal to I R2, V3 will be equal to I R3. Adding, so we have V1 plus V2 plus V3, I common, R1 plus R2 plus R3. So V1 plus V2 plus V3, nothing but V. So V is equal to I R1 plus R2 plus R3. Question number 1. Also by Ohm's law, if R is equal to resistance of the combination between A and B, then current is I, total resistance R. So V should be equal to IR by Ohm's law again. So number 2 question. So comparing 1 and 2, so we get R is equal to R1 plus R2 plus R3. So total resistance in a series combination is equal to the sum of individual resistances, and total resistance is equal to more than any of the individual resistances. Then what happens if number of resistances are connected parallel? Again by Ohm's law, take this example. V the potential difference between A and B, I the total current flowing in the circuit, R1, R2, R3 connected in parallel. In this case, potential difference across each resistance will be same, but current through each resistance will be different. So let I1, I2 and I3 be the currents through each resistance R1, R2 and R3 respectively. Then by Ohm's law, I1 will be equal to V upon R1, I2 will be equal to V upon R2, I3 will be equal to V upon R3, and if we add them, I1 plus I2 plus I3, be common, 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now, if R is equal to equivalent resistance between A and B of the combination R1, R2, R3, I the total current, then I should also be equal to V into 1 upon R. Total current is I. So comparing 1 and 2, again we have 1 upon r is equal to 1 upon r1 plus 1 upon r2 plus 1 upon r3. So in parallel combination, the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of the individual resistances. So in parallel combination, equivalent resistance will be less than the smallest of the individual resistances. So this is all about electric current, Ohm's law, resistance and factors upon which resistance depends. So ਜੇ ਵੀਡੀਓ ਵਧੀਆ ਲੱਗੀ ਮੈਨੂੰ ਸੁਜੈਸ਼ਨ ਦਿਓ, ਮੈਂ ਹੋਰ ਬਹੁਤ ਸਾਰੇ ਵੀਡੀਓਜ਼ ਲਗਾਤਾਰ ਪਾਉਂਦਾ ਰਹੂੰਗਾ ਔਰ 9th ਕਲਾਸ ਤੋਂ ਲੈ ਕੇ 12th ਕਲਾਸ ਤੱਕ ਸਾਰੇ ਅਲੱਗ-ਅਲੱਗ ਟੌਪਿਕ ਤੁਸੀਂ ਮੇਰੇ YouTube ਚੈਨਲ ਰਿਕਸ ਕਨਸੈਪਟਸ ਐਂਡ ਮੋਟੀਵੇਸ਼ਨਲ ਟਾਕਸ ਦੇ ਜਾ ਕੇ ਦੇਖ ਸਕਦੇ ਹੋ। Next video, heating effects of current is coming soon. So all the best. God bless you. Till then, goodbye. Sat Shri Akal.